Hello again. Today, we'll look into the technology used to not only pass the Facebook AI research machine learning tests, but how we found undetected errors in their training data. As usual, after some theory today, we'll run a demonstration to show the working system in action. We'll also see the next step past machine learning on the path to NLU, or natural language understanding, extending the test with an example that appears to be a challenge for the machine learning paradigm, even with thousands or tens of thousands of examples. You can select the specific part of the video from the contents area or read the article in Medium if you prefer.
The important part of the theory today is just to get our terminology right, because in a meaning-based system you have the descriptions of the meaning elements, but we also have the description of the syntactic elements, and it's important to keep those two separate but clear. So here when we look at the semantics, you can see that meaning is broken into either predicate or reference. So it either relates things or it's something that you can reference. In terms of syntax, there's three examples. You've got an argument, which is like a traditional noun, if you like. It's the thing that a predicator then converts into a predicate, and then you've got a modifier, which is changing that noun, if you like. So there's our terminology: argument, modifier, predicator, which is the syntactic model, and then we've got the referent and predicate, which is the semantic model. Okay, here what we're going to do is look at the different types of phrases that are embedded in longer sentences. So there we've got the running of the race was exciting, and in the case of the running of the race, that's a phrase sitting inside that sentence. Running is being used as a predicate in that phrase, but it's being used as an argument in the sentence. So you could effectively paraphrase that with the running was exciting, and if somebody said, what running? You could say the running of the race. Similarly, this second example, the running racer stopped. Running is being used again as a predicate because, after all, it is, in terms of its meaning, it is a predicate. And in that case, it's being a modifier. It's the racer details. So again, paraphrase, the racer stopped. And then the last example, the girl's gift of the prize was unexpected. A gift is the thing that you've given. So the predicate there is giving. There's a whole paper that took something like 5 years just to do the analysis of how those types of phrases are put together. But the girl's gift of the prize is being used as an argument in the sentence, and so you can see there that the resulting sentence is the gift was unexpected. Okay, so that's just introducing the different terminology. So there's a bunch more examples. The key point is when you look down that semantic category, you can see there's a lot of different predicate cases. But on the far right-hand side, you've got the part of speech that would traditionally be representing that. So you've got nouns, verbs, adjectives. We don't have adverbs in there, but adverbs would be in that category as well. We actually make another fine distinction there between how, when, and where, for instance, which traditionally would be known as an adverb. And then we've got adposition. So prepositions in English are also predicates. And that's really the secret to us being able to explain our terminology, because here we've got the new terminology that explains much more effectively the ideas that we've had in the old terminology, but the old terminology implemented a lot of ambiguity, as we've seen in previous sessions. The other part about a predicate is that there's a number of arguments that it can take, and then there's various other conditions. That the action start class also tells us a number of different things about that particular predicate. But if we just look at roles to make the point, so the predicate give, as in that sentence, John gave the prize to Beth. There's three different roles there. There's John, who's the one doing the giving. There's the prize, which is the thing being given. And the third argument is to Beth, the person who's receiving that particular prize. So that's the concept of three roles, and it's the meaning-based element of that role that we care about. It doesn't matter how you come about those in terms of the syntax, but bottom line, there's three roles there. Equally, if you're running, there's only one role there. So then we've got a traditional adjective, tall. So Rob is tall Rob is doing whatever. That there's a modifier example. So you can see the different predicate types there. Okay, this is our example of how we use that information in context. So there we've got John traveled to the hallway, and this is what we've used in order to pass the Facebook AI research tests, the so-called bAbI tests. So what we're doing here is we're putting into context based on the decomposition of those sentences, based on actor and predicate and so forth. The meanings of those things. And when a question comes in like that, we intersect that context and then we take the answer from that intersection and produce a response. So John moved to the bedroom. There's a predicate to the bedroom, which has a particular meaning where it is not in the bedroom at the start of that sentence, or at the end of the sentence. That's the location of whatever the rest of that sentence was. If you journey to the bathroom, it's the same concept. And the meaning of to is ambiguous until you actually know the full phrase. And that's part of the disambiguation that's taking place as we're going through this. So what we'll do, we'll just go to the end here where Sandra has a number of different elements, all which make sense. And then we get a question which relates to all of them, and then we have to choose a particular one. And you'll see how the intersection produces that level of ambiguity, and then the system produces the correct answer. Also remember that pattern theory is based on only two types of representation. There's sets and there's lists. And here what we're seeing is a set of information that's differentiated by its particular semantic role, or in fact the predicate itself. And as a result of that, when we're doing these comparisons, we're doing it without any complexity. It's either this matches or it doesn't match. So there we see Sandra journey to the kitchen, travel to the garden. We can choose the correct answer based on what was most recent. And that's the reason you need a list of things, because if you didn't have the list, then you wouldn't know what the latest one was. So I think we're going to have one more example with Sandra. She's moved to the kitchen. So now we've got 4 cases with Sandra. And so let's have a look at, now that she's in the kitchen, because she's just moved there, let's see what question we get. Where is Sandra? So that's a state. That's the current position. There's our intersection. The bottom one is Sandra moved to the kitchen. And because we've said where is Sandra, that's the latest. Where was Sandra would have given us the 3 answers below. Okay, so that's what's going on under the covers. And now we can go onto the actual example of competing with the Facebook test. So what Facebook was trying to do is make this a test that can keep improving. So rather than focus on what the technology can do, the plan that Jan LeCun was talking about just before he headed up that group, he was talking about how scientists need to set the targets for what we're after and then work out how to get there. And then once you've gotten there, you keep pushing the goalposts to make it more and more complicated. What's really happened with Facebook, in my opinion, is that they've started with the best of intentions. They've limited it, instead of trying to pass that particular test, they've limited it to passing the test with machine learning, not AI. And then rather than make the tests more complicated to do things which the machine learning technology doesn't do well, they've just focused on improving the algorithm. And so to me, it just fits into that category of AI research where we're working on the wrong problem and we're trying to get better and better at solving it, because we can actually measure our improvement rather than aiming at the right target and solving that. And at the end of today, I'm going to show you what the next level of Facebook test should look like. I guess we can call it Pat's bAbI test. Okay, so for us, we want to just keep these tests getting harder so we can keep improving. So firstly, this is what one of the tests looks like. So this, as you can see, task 8, we're just choosing
moved to the bathroom.
one of the random examples.
To the bedroom. Mary got the football there. John went to the kitchen. What is Mary carrying?
The football.
John went to the bedroom. Mary dropped the football. What is Mary carrying?
Okay, so this should look like the example we just demonstrated
Mary took the football there.
a moment ago.
Sandra went back to the office. What is Mary carrying?
The football.
Sandra got the milk there. Mary went to the bedroom. What is Sandra carrying?
The milk.
Sandra moved to the garden. Daniel journeyed to the hallway. What is Sandra carrying?
The milk.
Okay, so there's an example, and for a human being, if you did 500 of these tests, you probably wouldn't be able to answer any of the questions by the end because it would be pretty mind-bending. But the concept is that we should be able to do this with machines, and in reality, we passed 9 of the 20 tests. That was just as far as our resources would stretch. But what we'll talk about today is just how we passed one of those tests and what it shows about the decomposition of English. Okay, so the 5th test is about transfers. So if you give something to someone and then they take it and then they drop it or they put it down, the test is just keeping track of who has those elements at a point in time. And here what we're seeing is a logical structure, the semantic representation for give. So in the case of John, let's see, giving a ball to Bill, at the start, John doesn't have the ball and Bill does have the ball. And then after that, the change of state is that Bill does something because Bill is giving the ball to John. So Bill does something which causes Bill to not have the ball, and then at the same time, John to have the ball. And that INGR, the ingressive, just says that's an instantaneous change of state. Activity takes place. So, and you can see take is a very similar change of state. So what we're doing is we're saying that the meaning of these different words, whether it's give, take, have, put, pick up, put down, all relate to have. So the meaning of that is have, and then these other semantic elements are the things that we're going to manipulate as we recognize sentences. So this is from our archive article. It's just a table that's showing the different types of words. So what have we got there? Have, own, possess. We've got pick up. See at the bottom. Handed, you can hand it to someone, you can carry it, you can discard it. So all of those things vaguely have some relation to manipulating have. If it's a positive polarity, well, at the end of that activity, then you have it. If it's a negative polarity at the end of that activity, you don't have it. So give is negative in that respect. But we're just showing that this is how we approached it as a programmer, if you like. Our patterns were underlying meaning of have, and then we've used these other patterns of or patterns. The atoms of meaning are those different elements that we've just discussed. Okay, and what happened when we ran the tests? Well, we found that we got failures, and we were surprised. And so when we investigated, we found in some cases the assumptions that we'd made about the meanings of the sentences from the Facebook data meant one thing, and then our tests were failing for some reason. So here we've got, we'll look at the failed line. So just before the failed line, we've got what did Bill give to Jeff? You've got the apple. Then you've got Jeff put down the apple, so no, Jeff doesn't have it. Bill passed the football to Jeff. What did Bill give to Jeff? So if Bill passes the football to Jeff, then Bill is giving Bill is giving the football to Jeff. So you would think that would be the correct answer, the football, but it failed because, well, we'll have a look at why. Okay, so what we're seeing here is that there was a training data error. So it's the garbage in, garbage out risk of machine learning that if the data doesn't reflect exactly what you're expecting it to reflect, then your test system is going to produce the same errors that your input system told them that they should produce. And you can see there, line 13, Bill passed the football to Jeff. And then the following question, what did Bill give to Jeff? The answer that's being claimed to be right is apple. Well, clearly it's football. And it's referencing line 10, which is Bill handed the apple to Jeff. So the reference should have been to line 13. And as a result of that training error, the Facebook team were getting the correct answer according to their data, but it was completely unknown to them that they were getting the wrong answer. Here's a different example. So here we were also surprised that Bill took the football there. You can see there on the second line. What did Fred give to Mary? So that's coming from the first line there. But then who received the football? So we would say that if Bill took the football with the only sense that's being allowed in these. So if you take the football there, it's not like you're carrying it, which is one of the meanings of take. It's actually the real take where you take it from someone. So Bill took the football. Our system then says who received it. Well, if you took it, well, then you've received it, and so you can see that our answer is Bill. They've ignored that and just said that Mary is the correct answer. So it's that type of thing with machine learning that you would have to say you can never cleanse the data, or you can never, if you're not understanding the data in the first place, how can you expect to build a system that is then going to use that information in the future? So what are we doing next? Well, we've got more decomposition. Our focus is on decomposing language into these meaningful elements. And they're quite low-level elements depending on whether we're looking at letters being converted into words and words being converted into meanings, or word senses or word definitions being composed of other elements. We've got some ways to go, but for the tests like the Facebook tests, it's more than capable now of getting the correct answers, even when there's errors in training data, because at the end of the day, machine learning needs training data and NLU doesn't need training data outside of the experience that gives you the correct answers in the first place. So we think there's a lot of promise with further decomposition. As I've talked about previously, WordNet provided a reasonably good start, but once you convert language into predicates and referents, and you start that level of decomposition, it really changes the game in terms of what our capabilities are in the future. And let me just take you through, to finish today, with how And let me just finish today by taking you through an example of what the Facebook test should look like. So this is Pat's bAbI test. And what we're going to show is that as we use the Google speech-to-text interface, I'll be talking about how we're using the Google to trap my voice. You can see some errors in it. So it's not a perfect technology, particularly when we start getting around more complicated sentences. What you'll also see is then the back end of Pat is then going to be answering the questions in the same way that the bAbI tests will answer them. So this is what the Facebook AI research and the other big IT companies that are focused on solving AI, they should be trying to pass this test with either their machine learning technology or any other technology that they've got. Okay, now I'm going to use the Google technology that does the speech to text in English in order to demonstrate both the accuracy of that and then what the bAbI test of the future will look like using real sentences, not those simplistic sentences that we've seen so far. When I click on this button, it'll be passing control to Google, and then we'll see the text that comes back in. So that's the plan. Beth picks the milk that the milkman took there up. Okay, we can see the first problem here. It's missed Beth. So we've got milkman took there, and there is not the correct there. Let's just try this again and see what happens. Beth picks the milk that the milkman took there up. Okay, so let's just type it in because we're not going to get the answer. It's pretty determined. Picks the milk that the milkman took there. It's not there. It's there. Up. Okay, so we enter that into context. So we're up and running. This is great. Okay, now while it does that, we're going to now we're going to test. Who picks up the milk?
Beth.
Who picked up the milk? Oops, sorry, I forgot to press the button.
The milkman.
Who was carrying the milk?
The milkman.
Did Beth carry the milk?
She does.
Interesting, it says she does rather than she did because, in fact, we're getting the correct confirmation of tense there. Did the milkman carry the milk? Milkman carry the milk.
He did.
So there we have it. That's the demonstration.
So that's it. The Facebook AI research team has set a simple path to benchmarking, and we're now pressing home the edge with NLU by showing what a future step is for any aspiring machine learning enthusiast. Next time, join us to look at the problems around word sense disambiguation, a problem once thought to be unsolvable without a universal encyclopedia. Finding the valid word senses has been a key focus necessary to implement NLU because the word senses of the predicates determine the relations for meaning. See you then.